Okay, so in this video, we're going to discuss alpha and beta roots. I'm going to give a summary of everything that you need to know. So whenever given a quadratic equation or function, we always expect to get two answers when you solve it. And those answers are going to be called alpha and beta if they are unknown. So if we don't know how they look like or what they are, we call them alpha and beta. Then there are a few equations that you have to know regarding the alpha and beta solution. So we're saying, without even you solving the quadratic equation, let me give you an illustration. X squared minus 6x, let's say, plus 8, giving us a 0. We know to say when you solve this, the two answers you're going to get are simply, there's a 2 and a 4. That's what you're going to get using the quadratic equation. This is what you get. Now, imagine you didn't know that the answers are 2 and 4 because this is your alpha or this is your beta. The naming really does not matter. You can call this your alpha, you can call this your beta. The order is not important. All we are saying is that the alpha and beta are supposed to be the solutions, the roots of the quadratic function given. So the first equation is that if you were to add alpha and beta, you should always get negative b over a. That's what we are saying. So even if we didn't know that the answers is 2 and 4, if we add them, this is what alpha and beta tells us to say. In as much as you don't know the answers yet, if we were to add them, we'll get negative. From this question here, our b is negative 6 and our a is simply 1. You notice here you're getting a 6, right? Which is the same thing, you adding 2 plus 4. You get what? You get a 6. So that's the importance of alpha and beta. They tell us about the behavior of the roots before we even find the roots. So this is alpha times beta. The other equations that I want to stress on is the expansion ones, alpha squared plus beta squared. This here is the same as alpha plus beta squared minus 2 alpha beta. Then the fourth one is alpha minus beta. This is the same as alpha plus beta squared, then minus 4 alpha beta. That's how it looks like. Yeah, then if I was to give you alpha squared, if they say alpha cubed, and beta cubed, this would be alpha plus beta, then cubed minus 3 alpha beta, then you have alpha plus beta. These are simply formulas that you need to be familiar with. Yeah. How we derive them. So starting from equation number 3 going down, the way that you derive them is, in case you forget, if I ask you alpha squared plus beta squared from this is the equation that you have is equal to 0. You know to say, you look at the number given here, the exponent is 2 throughout. So you're going to get alpha plus beta, put a 2 there, expand this expression. You're going to get alpha squared plus 2 alpha beta, then plus beta squared. Then from this expression, we're going to make alpha plus beta, alpha squared plus beta squared to be the subject. So we're going to get this expression and this one to be the subject, meaning we take this on the other side to leave these two alone. So we're going to have alpha squared and beta squared. These two are equal to this, which is alpha plus beta squared minus, because when this goes on the other side, it becomes negative, 2 alpha beta. This is basically what you get. The same applies when they put a cubic expression there. The same thing, alpha 3, alpha cubed plus beta cubed. You still expand alpha plus beta cubed. When you expand this, you get alpha cubed, then minus 3 alpha squared and beta, then minus 3 alpha and beta squared, then you get plus beta cubed. Then you take these two on the other side, then you remain with this and that. Yeah, so this is how we simply got the fifth equation, the alpha cubed and beta cubed. This is what we come up with. This the one for minus. So if they give you alpha squared minus beta squared, you just have to say alpha minus beta, you square this to be alpha squared, then you get this is going to be This is going to be, let me give it to you here, just a minute. Let me write it properly here because most people forget this. So we can make this the sixth equation. If they ask you for alpha squared minus beta squared, this is the same as alpha plus beta and alpha minus beta. These are simply the same as this. Now we know what alpha plus beta is. It's negative b over a. You know that already. The only problem was the alpha minus beta. That's the reason why I gave you the expression for alpha minus beta, which is the square root of alpha plus beta squared minus 4 alpha beta. This is what you have. So you just have to master these equations so that whenever they ask you questions, like find from this same expression, if I was to ask us to say, this is equal to 0. If I ask you to say find 1 over alpha squared, let's say minus 1, plus 1 over beta squared minus 1, we have to combine this. So the common denominator will be alpha squared minus 1 and beta squared minus 1. Then on top, you get beta minus 1 plus alpha squared minus 1. This will lead us to have alpha squared plus beta squared minus 2. Down, you can multiply this. This is going to be alpha squared and beta squared minus alpha squared minus beta squared, then plus a 1. We always need to put the expression in values that we are comfortable with. Because we don't have the exact expression for alpha squared plus beta squared, we replace with what alpha squared and beta squared are. This is simply this from the equation I gave you, minus 1. The guy at the bottom, this is the same as alpha and beta with a 2. Then minus, this is the same as minus alpha, the middle part. When I factorize the negative, this part, it will be like that. So we know what this part is. It's alpha. It's alpha plus beta squared minus 2 alpha beta. Then there's a plus 1 at the end, so that we know what this is. You know what alpha plus beta is. You know what alpha times beta is. So then you do your replacements. So this is how we handle questions that have to do with alpha and beta. The only interesting thing that can be done is as saying we can recreate the equation. So the quadratic equation, you can recreate it. So if you know to say an equation has these two roots, alpha and beta, you can recreate it by saying alpha is equal to sum, then the product this side. In short, we're just saying if these are the two integral coefficients, meaning the quadratic can be gotten by adding them here, then put an x, then multiplying them this side. So the answers were 2 and 4, remember, for our example. So this is going to be x squared, 2 plus 4, that's a 6. There's always going to be a negative here, by the way. Then you multiply them here, it will give you 8. So this is the quadratic equation. So I'm saying, despite the integral coefficients that they give you, if I give you x squared minus 6x, the same guy, then I ask you to say, I tell you to say, this has roots alpha and beta. Find a new quadratic whose roots are 1 over alpha and 1 over beta. Okay, so from these expressions given, you have to get the sum. What is the sum? You sum up this. 1 over alpha plus 1 over beta. When you add this, you get alpha plus beta on top. Down you get alpha times beta. You know to say the sum was what? The sum was 6. The down part is simply 8. This is going to give us 3 there. I mean 2 there is 3 and 2 there is 4. Then the product is 1 over alpha times 1 over beta. This is 1 over alpha beta. We know the sum, I mean the product is simply 8. The alpha times beta is 8, right? So we're going to have 1 over 8. So the quadratic equation with 1 over alpha and 1 over beta as the roots is going to be as follows. We put x squared minus the sum is 3 over 4. Then you put an x plus the product is 1 over 8 is equal to 0. So this is what you get. You can break it down by multiplying throughout by 4 to make it into a linear or rather a straight expression without having fractions or rational parts. So this is what you get. So the key here on alpha and beta are the formulas. And how do you know this equation has to do with alpha and beta? They will say in the question, Because most people confuse this with a discriminant. How do you know you have to use the discriminant? They will say the nature of the roots. So if you need to use the discriminant, they will say, is it one real root? So if they say one real root, then you know to say you need to use this formula to get whatsoever they're asking for. When they say two real roots, you know to say the discriminant is supposed to be an inequality. This is going to be that. If they just say two real roots, meaning it's greater than 0 strictly. But if they say real roots, because could be 1, could be 2, so here we're going to have the middle version. This is going to be this. If they say it has real roots, they have not specified whether it's 1 real root or 2 real roots. So we say it could be greater than 0, which is this case, or it could be equal to 0. Then if it has complex roots, the discriminant that we use is b squared minus 4ac less than 0. That's a discriminant that you use. So the only time you use the discriminant is when they specify that the nature of the roots is either real, true real, or just plain to say real roots or complex roots. Yeah, that's basically what we have.